So given the coordinates 2, negative 2, this is in rectangular form. I want us to find the r and theta that would make this, that would be the polar equivalent of these points, or this point, I guess. So this would be x and this would be y. So we have a formula, guys, to figure out what r is. So if you guys look in your box, if I know x and y, what's the formula to figure out r? Yes. R is equal to the square root of x squared plus y squared. So don't be sloppy, guys. Make sure you guys use parentheses. So parentheses 2 squared plus negative 2 squared. And if you add those together, you get square root of 8. And then if I do a factor tree on this, I'm going to get 2 square root 2. Now, when we do these problems, remember we did an example on Wednesday where I showed you guys the radius can be negative. Do you guys remember that? And we reflected it across the center. Do you guys remember that? When we do these problems, you're safe to just keep it as positive, okay? If you're wondering which one it would be. Because this tells you something about your angle. So if this is my angle, which quadrant is this point in? Good. This would be in quadrant 4. So we need to keep that in mind when we're trying to figure out what the angle is. So if I want to find the angle, we have a formula that says tangent of theta is equal to y over x, which means that theta is going to be equal to the tangent inverse of y over x. Is everybody cool with that? Does that make sense? Now, these are calculator problems. Now, this one, technically, you guys should be able to do without a calculator, but if you guys use your calculator on this, I won't judge you, because I would if I were you, because don't you guys want to make sure it's right? So this is the tricky part. What does your calculator say this is? Negative what? Negative 45 degrees. However, in this chapter, we don't want it in degrees. We want it in radians, okay? Now, if we think about where this would be on the coordinate plane, is that quadrant 4? It is. Negative 45 degrees, guys, is that would be going down, right? Right? So that would be negative 45. However, I want this between 0 and 2 pi. So if this is in degrees, what could I add to this to make it positive? 360. So add 360 to this, and I would get 315 degrees. But again, I don't want it in degrees. I want it in what? Radians. So this just comes from our unit circle. Or if you guys remember the conversion, you guys can use your calculator to convert it. What is the radian equivalent to 315? 7 pi over 4. Good. So that means that theta is equal to 7 pi over 4. So we have r and we have theta. So that means our answer is r comma theta is equal to 2 square root 2 comma 7 pi over 4. I want to write that different. Don't like that. Questions? No? You guys look unimpressed. Let's do a harder one. C. All right, so a good rule of thumb, guys, because this is where students lost points last year, is first identify which quadrant this is in. So if X and Y are both negative, which quadrant should our answer be in? Quadrant 3. So that's important because if we use our calculator, guys, do you guys remember, because you guys just did an inverse, right, on your calculator? Remember, the inverses only tell you so many quadrants. Remember, cosine is only quadrants 1 and 2 for inverses. Tangent and sine are both quadrants 1 and 4 for inverses. So your calculator may help you get there, but it's not going to maybe give you the exact answer because we have to use our brain. So the first thing I would still do is figure out what r is. So r is equal to the square root of x squared plus y squared. So r is equal to the square root of negative 1 squared plus negative root 3 squared. Parentheses matters. So if I add those together, I get the square root of 4, which means r is 2. Hooray. Cool. So to figure out theta, tangent of theta is equal to y over x, which means that we could say theta is equal to tangent inverse of, what's y? Negative square root 3 all over negative 1. What happens to the negatives? They cancel, and then anything divided by 1 doesn't change. So theta is equal to just tangent inverse of square root 3. Thank you. So what would that give me? 60, which is the same thing as pi over 3, because you want an angle. So theta is equal to 60 degrees, but that's the same thing as pi over 3. Is everyone cool with that? You don't want your calculator in radian modes because is your calculator going to tell you pi over 3? It's going to give you the decimal of pi over 3. I have no idea what that is. So I don't think you guys would either. So don't do that. Now, this is why this step is important. Because is pi over 3 in quadrant 3? No. So what is the correct angle then if I want a pi over 3 but in quadrant 3? 4 pi over 3. And a way you guys can think about that too is, what's the period of tangent? Pi. So what I could do is take this angle and add pi. Okay, and that will give me the correct angle. So just make a note to yourself so you guys remember why we did this. This is not in quadrant 3. So that means that theta really is 4 pi over 3 because that is the equivalent angle in quadrant 3. So what's my final answer? 2, 4 pi over 3. Okay, questions? All right. Now, before we do these, I'm showing you guys these because they're kind of cool. These are not the most important things. Last year, the students, I felt like were stressed on these problems. Okay? These are just different types of problems I can give you, but they're not the most important thing in the world. So I'm giving you guys a huge hint when I say that. All right, so example. Transform r is equal to 6 cosine theta from polar coordinates into rectangular coordinates and then identify the type of graph. Okay, so this is where we have to be kind of clever. So this is the information we know, right? So thinking about what I know about these functions so far, do I have anything that's the same as R? Using my notes, what do we say R is equal to? Do you have a formula for that? We just did it, guys. Thank you. Square root of x squared plus y squared. So why does that help us? Well, we know that R is equal to 6 cosine theta. That's what they gave me. So I want to transform this into rectangular coordinates. So do you guys agree rectangular coordinates have x's and y's? So right now I have R. How could I get the x and y out of this radical? What could I do to both sides? Square both sides. So if I took this equation right here and squared both sides, that means that R squared is equal to x squared plus y squared. So what I'm trying to do is be clever and show you guys that what I could do is, this right now is R, right? To make this become R squared, do you guys agree I could just multiply this by another R? Because R times R is R squared. But if I multiply this by R, I have to multiply this by R. So I'm going to multiply both sides by R. And I'll show you guys why here in a second. So R times R gives me R squared. Now this times R is just going to be 6R cosine theta. Okay, you guys follow me? So now what I could do is, I know R squared is this. So I'm going to take this and plug that in right there. So that means that x squared plus y squared is equal to, now, if I want to convert this whole thing into rectangular coordinates, do you guys agree I don't want an R in the problem at all? So this is where I'm going to challenge you guys right now. How could I rewrite this? So look in your notes. Where do I see anything like this in my notes? Say again? Yes, good. Hey guys, good job. What's that? X, good. Should I say it? Say it again. X, right? R cosine theta is X. So how could I rewrite this then? It's just 6X. So this is just 6X. Isn't that crazy? It's a crazy world. So now what I could do is, we're not done. We have to figure out what type of graph this is. So I want you guys to think about everything you guys have learned in my class since August. Which type of equations have x squareds and y squareds? Circles. So what we need to do is we need to rewrite this to figure out what the center is and what the radius is. So in order to do that, we want all the x's and y's on one side. So I'm going to subtract 6x from both sides. So I'm going to get x squared minus 6x. I'm going to leave some space on purpose. Plus y squared is equal to, right now I have just a 0. So do you guys agree that in order to write the equation of a circle, do you guys remember we had to complete the square? So how do we complete the square here? What do we identify? B. So B is what? -6. And then what do we do to B? Divided by 2. And then square it. Good. So what's my B over 2 squared? 9. So I'm going to add 9 right here. Which means you guys agree I have to add 9 over here. So, based off this, if I'm completing the square, how could I factor this now? X minus 3 squared plus y squared is equal to 9. And if you guys are confused or you forgot what that means, remember whatever this number is, that's what goes right there when you factor it, okay? All right, so what's my center? Three comma 0, good. Because you guys agree there's nothing right here with the y squared, so just be 3 comma 0. What's my radius? 3. And we know this is a circle. Okay? So here's the cool part. If you guys opened up Desmos, don't do it right now, but if you guys open up Desmos and graph this, it would be a circle. If you told Desmos to graph this, Desmos has a polar mode. If you guys graph this on Desmos using polar mode, it would be a circle. And if you guys overlap these graphs, they'd be the exact same. But do these equations look the same at all? No. That's the weird part, and that's actually kind of the cool part of these. Okay, so now I can tell you guys this. You're not going to get tested on this. I'm just showing you guys how these can transform. It's actually kind of cool. All right, last one. So now we're going to go the other way. Bless you. Okay, so if I'm using the same thinking, guys, if I want it in polar form, remember that's r comma theta. So do I want any x's or y's in this equation? No. So what could I do to change some things? Yeah, don't we know that x is the same thing as r cosine theta? And then if I use that same logic, what's y the same as? Yeah, r sine theta. So I'm going to take this and plug it in there. And I'm going to take this and plug it in right there. So this one's actually pretty easy. So 4 times r cosine theta times r sine theta is equal to 9. So if I simplify this, I'm going to get 4r squared cosine theta sine theta is equal to 9. Now, like I said, I'm not going to test you guys on this, but like if you guys were to get here, I'd be cool with that. Okay, but technically, just to show you guys how the math is actually kind of cool here, we actually could go further. You guys took a test last week or the week before on double angle, half angle, and all those formulas. Okay, so do you guys see how there's a 4 here? And I have a cosine theta, sine theta. Do you guys remember any of those formulas, or are those out the window? Check this out. That's still the same, right? Is that legal? Can I do that? It's kind of weird I did that, right? But that's allowed. What's this the same as? Sine of 2 theta. This right here is the sine of 2 theta. That's a formula, the double angle formula. So this becomes 2r squared times the sine of 2 theta is equal to 9. Now, this is important that we notice that because you guys are going to learn in the next section that we're going to take today, Monday, Tuesday to do, how to graph something like this. And sometimes they'll be pretty. Sometimes they'll look like flowers, for real. And sometimes they're going to look like snails. Or they'll be boring and just be lines, okay? But I'm hoping this goes smoother than, I'm going to turn this off because I'm